is we could just draw the graph at different stages. What I mean by that is, rather than making a table, we can make this clearer by drawing 4 graphs. First, we'll draw 4 tan x. Then we'll draw 4 tan 1/3 x. Then we'll draw 4 tan 1/3 x plus pi. Then we'll draw, and so on. So we'll build the graph up, drawing it step by step. It's not as easy as just making a table, because now we have to make 4 graphs. But I think it'll help you to see what's going on. Okay, so first let me just draw my x and my y. So there's my x, there's my y, and we'll call this here minus pi, minus 2 pi, pi and 2 pi. Okay, so the first one in red, well, let me just write down what we want. Yeah, no, in red. Y equals 4 tan x. Actually, even before I start, I'll put down y equals tan x to get us started. This here is pi over 2, 270 degrees. Okay, so in green, just good old tan x, which goes like this. Yeah? Oh, sorry, I went too far, didn't I? It'll do. And then the next one is from here. It'll do. And then the next one is from here. And then this one is here. And then the next one is coming in this way. Okay, so that's tan x done. Now let's draw 4 tan x. Well, what's the difference? It's just stretched. So it'll just be pulled up, but we can't really tell a difference because it's still going to infinity anyways. So for my sketch, I can't really tell a difference for this. It doesn't really look any different. Okay, well then let's go to the next one. 4 tan 1/3 x. Now we will see a little difference here, because now it'll be 3 times bigger. So instead of breaking at pi over 2, it will break at 3 pi over 2, which is here. So the graph now gets pulled all the way over to there, and then all the way over to here. Yeah. And then there's another one coming in like on this side, and then there's one going on the other side, but we can't really see it, so I'll just leave it out for the moment. Okay, well, I'm sorry, I should have done that in, if I'm keeping the colours the same, I should have done that in blue. Let me just write this in blue. Y equals 4 tan 1/3 x. Okay, the next one now. Y equals 4 tan 1/3 x plus pi. Yeah? So that moves it to the left pi units. So instead of being here, it will be, that point will be moved to here. So that will be where the middle is. And then the break, instead of being here, we have to move it pi, so that will be here where it breaks. So instead of breaking here, it'll break somewhere. Wait, where here? So it'll be somewhere like out here. So the graph now looks like this. And finally, the actual answer. Y equals 4 tan 1/3 x plus pi plus 1. So this gets moved up to here 1 unit. So our final answer will look something like, breaks here. Whoop. Let's see how good or bad that is by drawing this here. Oh, come on, piece of junk. No, I'm not using. I'm trying to use this one. For goodness sake! Right, Wolfram Alpha. Okay, let's have a look here. Yeah. Can you just read out, what was it? Oh no, I have it here. Y equals 4 tan x over 3 plus pi over 3 plus 1. So I want graph this from minus 2 pi to 2 pi.
Wow.
Yeah. That's what I was drawing here. Yeah. So the middle is about, what would you say, about here? If I zoom in. Is it about here, let's say? At minus pi, so that would be about, about here. Yeah. There we go. That's where the middle is. So you can see they don't ask you to draw. In fact, I've never ever seen them ask you to draw tan x in the exam. That's never happened. You know, I've been here 10 years, and the exam has been around for I think like 13 years, and there's 2 exams a year, so that's 26 exams. Not one of them have a tan x in it, because I think it's too difficult for the exam. It's too difficult for the exam. They always ask sine and cos, which I guess is good news. Okay, we just go back. Yes, what else do we need to see? The video's up on YouTube. Oh, watch my video. Come on, like and subscribe. Thank you. Yes? B? Did I ask you to do B in this one? Did I?
Yeah, A, B, E.
Let me have a look. 1A, 1B?
Yeah.
1B?
Yeah.
For sure?
I just want to check here because I heard the
Okay, well, let me just look online then. Call out the equation, KJ. Plot y equals
2 sine bracket x over 4 minus pi.
X over 4 minus pi
Bracket
minus 2.
And
From
minus 6 pi and to 6 pi.
like this?
What's the number along on x actually? Pi.
Yeah.
Pi.
So here will be pi. Here will be about 2 pi. Here will be about 3 pi.
6 pi.
Yeah. What's 3 multiplied by pi? About 9.45. About 9.5. So there's 3 pi.
In case of an exam, do we write numbers or do we write pi, 2 pi, 3 pi?
Both are acceptable.
Pi.
Pi is easier to do, because then you're not wasting your time converting pi into a number. The graphing program doesn't care. It's no cost to it. In the exam, both are acceptable. What's not acceptable is if you use degrees when it specifically said radians. That's the only thing that's not acceptable. Yes, pass that up. Thank you. Where the heck am I looking? This one?
Yeah.
Let me have a look. 2 pi. Okay. Minus 2202 pi. Okay. Minus 2208 pi. Okay. Minus 2. Is that a minus 4 pi on the third line? If it is, it's wrong. Because you move it to the right when it's a minus. It should be, you should have 4 pi and 12 pi. Yeah. Okay, what's next? Dudes down the back, on the laptops. Are you mining for gold in Warcraft, or what are you doing? Essay. What I'm not talking to you anymore. What I'm doing now. Do you have more questions on this? If the two science students don't mind and they have something to work on, I wouldn't mind doing a couple of more mechanics, physics questions from past exam papers, because the questions we were working on, I did version 1, version 2 and version 3. I might as well finish it and do version 4. Just before... Oh, come... What the heck's happening? Yeah. No. YouTube channel. Physics dudes. Physics dudes. I made a playlist called Physics Mechanics. So what I want to put in this is, I don't particularly want to hear me as I'm talking. What I put in this playlist, yeah, here it is here. It's all the mechanics questions from the past exam I was doing. So you can see here, this is version 3, 09, 10, A6. It's a mechanics one. So you can see I have version 3, 2 and 1. There was only one mechanics in version 1. I thought this would be good for your revision if I make a playlist of all the 6 topics: mechanics, materials, electricity, fields, waves and atoms. So then at the end of the year, when you want to revise exam questions, you can do all the mechanics questions, and then when you get stuck, you can look at the video for how to do it. Yeah, I think this will be helpful. So I would like to finish version 4 of 0910, which is on Moodle, if you can open that. Science students, you're welcome to watch if you want, but if you have something you can work on that. Or do you have maths questions you need me to do? 2 more, okay. Now, if you're asking about first principles, I will ignore you. Yeah? 2e and f. Okay, what's 2e?
Y equals to negative 7 x squared plus 5x plus 4 at x equals 1.
Plus 4. X equals 1. So then y equals minus 7 plus 5 plus 4, which is 9 minus 7, which is 2. Yeah? Is that right for the y? And what am I asking you for? No, I'm not finished yet. What am I asking you for? The slope of the tangent at x equals 1. But I guess I don't really need y. You have y equals mx plus c. But if I put this point in, I can figure out the c. I have 2 equals m plus c. So I have c equals 2 minus m. So I get y equals mx plus 2 minus m. If I solve this and this together, I should have only one answer. mx plus 2 minus m, that should equal minus 7x squared plus 5x plus 4. Yeah. So that is 7x squared plus m minus 5 plus minus 2 minus m equals 0. B squared minus 4ac should equal 0. So m squared minus 10m plus 25 plus 56 plus 28m should equal 0. So m squared plus 14m plus 80. Did I make a mistake? 18m. 28m minus 10m. 18m. Thank you. Plus 81. 81 equals 0. So that means I have m plus 9 squared equals 0. So m equals minus 9. Is the second question similar to this?
Yeah.
Yeah, I'm guessing, am I right? I'm guessing the problem was here, you ended up with a result that had M and C in it. Yeah.
Thank you.
Which one was this, so I can write it down for people who are watching? 2E? 2E. Okay. Right, well, if you need to write that down, write it down. Yes, Monica? About what? Yes? Did I not give it to you in the question? And is it not in your notes? Wait, no, hang on, you don't need the C of nitrogen. I just remembered the question. The nitrogen is poured into the glass and it's already at its boiling point. At the moment it's a liquid. When it hits the glass, it becomes a gas. There is no increase in the temperature. It is simply changing its state from a liquid to a gas. Yeah, to the boiling temperature of the nitrogen.
But they should reduce or increase
What should be?
temperature.
Of what?
Because
Of what? Answer my question. What should be increased or reduced? Temperature of what?
glass and
Yeah, the glass is being reduced. At the beginning it's up.
so you have to know the temperature which is at primary temperature.
Hang on, just to be clear. Glass at room temperature. Nitrogen at boiling temperature. Nitrogen is poured in. The nitrogen changes state. It does not change its temperature, only changes its state. Yeah. And the glass will reduce. The glass will keep reducing in temperature until it's in thermal equilibrium with what's being poured into it. Yes, well, you should believe Monica then. Yeah. Like, I know she's not trustworthy, but on physics she is. Yeah. Because, she was telling me that she didn't get any sweets, and she gave the sweets to the classmates, but I know she kept all those bags for herself.
When my warm head and cold head meet each other, and they become like changing temperature.
Correct.
I don't know the temperature which is thermal equilibrium, but how can I estimate temperature?
The warm hand and the cold hand is a little bit different to this, because the glass, there's no heat source for the glass. The glass has heat energy in it. The cold nitrogen hits it. It's losing all its heat to the nitrogen. The nitrogen is gaining this. In other words, the heat lost by the glass is equal to the heat gained by the nitrogen, which is equal to the latent heat, because the nitrogen is just changing state. Okay, physics, if that's okay. Science students, are you okay with that?
Yeah, I'm not okay with the first derivative of certain elementary functions, 2n.
Yeah. Did you miss that lesson as well?
I missed that lesson, I don't
Dang.
know how to do it.
Dang. Which one?
2n.
What's 2n about? What type of function is it?
There's exponentials and logarithms. Natural logarithms.
Read it out.
9 over, oh my god,
E power 1
e to the power of y.
1
Yeah.
1.
y1.
1, just y.
Okay.
Plus log, natural logarithm 6 over y to the power of 5.
Okay. This equals, oh, is that a y? And this is a y?
Yeah.
Oh, that's a typo then. Yeah. That should be like an x then or something.
That's why.
Oh, it has a bracket with a dash. Yeah, okay. Right, so, well anyways, it's the same thing as differentiating this. True? Same thing as differentiating this. Same thing as differentiating this. Say this is the derivative here. Right, mechanics. Mechanics. Guys, did we finish version 3 of the exam? Maybe? Let's have a look. Let me have a look at what was the very last question I did was A6. Okay. Where's the new downloads? A6. Yeah, I did that. Only 7. Interesting. Physics students? Physics students!
Yeah.
Have you opened version 4? Okay. Let's have a look. Let's have a look. Question 1. Mechanics or not mechanics? Do you think if I kill Lee, a jury would convict me? Just wondering. No, listen. Chrissy, Lee, Bruce, Monica, Jerry, Andrew, Sean, Chu, KJ. Listen to me carefully. We are going to do version 4, 0910. I did not give you version 4, I gave you version 123, and we did 123 in class. Please go to Physics Moodle page, go to the 0910 folder at the bottom of the page, and open version 4. Question A1 is a mechanics question. We will do that in 20 seconds. Open it.
Done.
Okay.
Done. Okay.
Now,